Hi everyone. In this video, we will analyze the flanged sections. Flanged sections. Flanged section means it may be either T-beam or L-beam. Generally, T-beams are intermediate beams in slab and L-beams are the end beams in slab. While we are analyzing these flanged sections, there are two cases. In case number 1, XU less than or equals to DF. It means that the depth of neutral axis is less than depth of the flange. Suppose it is our section. The depth of neutral axis, this is the neutral axis. This neutral axis is within the flange. Then we can call the depth of neutral axis is less than or equals to DF. This is XU. This is DF. XU less than or equals to DF means the neutral axis is within the flange. This is case number 1. Case number 2. XU greater than DF means the depth of neutral axis is outside the flange. Suppose this is our T section. Now the neutral axis is somewhere here, right? Our neutral axis is somewhere here. Now XU is greater than the depth of the flange. This is depth of the flange, right? XU is greater than the depth of the flange. These are the two cases. In the case 2, there are two cases again. Case number 1, DF by small d value less than 0.2. Case 2, DF by small d value greater than 0.2. It means that, what's the meaning of this one? It means that suppose, as I said, if it is the T section, depth of neutral axis is somewhere here, but this outermost fiber will be having the compression of 0.45 FCK. This total complete flange, the complete flange is having the uniform compressive force of 0.45 FCK, and the remaining portion is not uniform. Then in this case, DF by small d value will be 0.2, right? The overall depth of the flange is having uniform compressive force of 0.45 FCK. Coming to this case, suppose this is the section we considered. This is our section. Neutral axis will be outside the flange and outermost fiber will be 0.45 FCK, but only certain portion of the flange is having the uniform compressive force of 0.45 FCK, the remaining portion is not uniform. The remaining portion is not uniform. DF by D ratio greater than 0.2 means only certain portion of flange is certain portion means only certain depth of the flange is having the uniform compressive force of 0.45 FCK. Okay, this is the meaning of this one. Right? If you want to determine the moment of resistance, you can refer page number 96, Annex G. Annex G. Here you can get the equations for the analysis of flanged section. Okay, you can refer page number 96, Annex G. See, this is page number 96, Annex G of IS 456. Now I am talking about the flanged section. If the depth of neutral axis is less than depth of the flange, the moment of resistance may be calculated from the equation given in G 1.1, means this one. Okay, these equations are similar as we studied the analysis of rectangular section. Same formulas we can use for flanged sections with the depth of neutral axis less than depth of the flange. What are the formulas we will learn there? See, in the case of XU less than DF for flanged section, and for rectangular section as well, we can use same equations. C is equal to 0.36 FCK B into XU, T is equal to 0.87 Fi AST. For depth of neutral axis, you need to equate C is equal to T. Then the depth of neutral axis will be XU by D, that is equal to 0.87 Fi AST by 0.36 FCK B into D. Right? Same formula. See, in page number 96 also you have the you are having this same formula. Same, XU by D is equal to 0.87 Fi AST by 0.36 FCK B into D. If you want to determine the moment of resistance, then you are having the formula here. If the depth of neutral axis XU by D is less than limiting value, means, see, if XU by D value less than the limiting value means you need to refer 38.1, these values. See, page number 70. In page number 70, you are having the limiting values for depth of neutral axis. For FE 250, XU max by D is 0.53. For FE 415, this value is 0.48. For FE 500, this value is 0.46. If the xu by d value is less than xu max by d is less than xu max by d then you can determine the mu value by using this one. What is this one? Mu is equal to 0.87 FIAST into D 1 minus AST FY by B into D into FCK. Now we will solve a problem. A T-beam of effective width 1200 mm and thickness of the slab is 100 mm. Effective depth is 460 mm. This T-beam is having 4 bars of 12 mm dia. The materials used are M20 grade concrete and Fe 415 steel. Determine the moment of resistance. This is the question. First, what we need to determine? First, we need to determine the xu by d value. How can we determine the xu by d value? Not xu by d value. First, we will determine the xu value. Depth of neutral axis. We need to check whether this xu value is less than df or greater than df. First, we need to check. Depth of neutral axis need to be determined. How can we determine the depth of neutral axis? C is equal to T. 0.36 FCK B into XU is equal to 0.87 F5 AST. Here 0.36 FCK means 20, breadth means 1200, XU we need to determine 0.87, Fi is given as 415, AST means here 4 numbers of 12 mm dia bars. Then XU will be 18.9 mm. 18.9 mm. It is less than depth of the flange. Means analysis is similar to that of rectangular section. Rectangular section. Right? Rectangular section. What is the XU max? XU max is equal to, this is Fe 415 steel, right? For Fe 415 steel, 0.48 into D. That is equal to 0.48 into, what is the effective depth? 460. That is equal to 220.8 mm. 220.8 mm. 220.8 mm means it is under reinforced section. Under reinforced section means you can use either T into Z or C into Z, right? Or you can take the help of page number 96 Annex G. Annex G. What Annex G is telling? Sections without compression reinforcement means this one, right? You can, when the XU by D value is less than XU max by D, you can use this formula. Am I right? Means mu is equal to 0.87 F5 AST into D into 1 minus AST Fy by B times D times FCK. That is equal to 0.87 into 415. We used 4 bars of 12 mm dia into effective depth is 460 into 1 minus 4 multiplied by pi 12 square by 4 into 415 by breadth is what's the B value? B value is 1200 multiplied by D. D is equal to 460 into FCK 20. Right? Now this value will be 73.85 kilonewton meter. Kilonewton meter. Right? This is our answer. You can also determine this MU value by using this one. T is equal to 0.87 into 0.87 Fy 415 into AST 4 into pi d square by 4 0.87 Fy AST multiplied by D minus 0.42 into XU. What is XU value? We got 18.9. 18.9. Right? What is the D value? Sorry, D value will be 460. Answer of this one will be 73.85 kilonewton meter. Same. You can also determine this mu value by using this one. You will get the same answer. Right? Thank you.